You have to.
Hello, can you hear me?
Yeah, perfectly.
Okay. Hello everyone. My name is Atharva Agaskar, and I'm a rising eighth grader from Jersey City, New Jersey, in the United States of America. I enjoy sports, and some of my favorite subjects are math and science.
Great. So we are ready, and you have a very interesting presentation. So please begin.
Okay. Am I allowed to share my screen?
Absolutely.
Okay, thank you. 1 minute.
We see your screen. It's perfect.
Okay, thank you. So hello everyone. Good morning, good afternoon, good evening, wherever you are. As I said before, my name is Atharva Agaskar, and for my science project last year, I wanted to find out the pH of soil and its effects on the plant's growth. So the pH basically stands for potential of hydrogen, which in simpler terms means the acidity or alkalinity of a certain substance, which in my case was soil, and its effects on how a plant grew. You might be wondering, how did I get interested in this topic? I picked up gardening as a hobby last summer, and I started watching videos on it and got really interested to find out how the pH of soil affected how the plant grew. In the current era, plastic pollution, acid rain, erosion, climate change, and many other problems are seriously affecting our soil quality. This is threatening food production and our environment's health. My project also correlates with the United Nations Sustainable Development Goals, number 12, responsible consumption and production, number 13, climate action, and number 15, life on land. Some background information to my topic is that soil pH is a factor that largely determines a plant's growth because it affects the number of plants and the number of nutrients that is available to a plant. For my science experiment, I wanted to figure out how much the pH of soil really affected the growth of a plant. I determined that fenugreek, a fast-growing legume, would be the perfect test plant for an experiment like mine, with a short data collection time. The purpose of my experiment is to determine which pH level provides the best conditions for optimum growth in the fenugreek plant. This experiment will benefit farmers and gardeners by helping them find out which pH level will supply the best conditions to grow the fenugreek plant in. The independent variable of my study will be the pH of the soil. The dependent variable will be the growth of the plants, which I chose to measure by the height of the plants. My constant variables will be the amount of water given to each plant, the location of the plant, and the amount of plants in each planter. The materials I used for my project are weighing scale, cardboard planters, soil, lemon juice, which is a pH reducer, baking soda, which is a pH increaser, a ruler, a precision pH test kit, pH testing strip, water, a strainer, a cup, fenugreek seeds, and an indoor plant growing light. My procedure consisted of two parts, the first one being soil preparation. The first step was to pour 100 grams of soil into 5 planters. Then I labeled each planter with pH levels of 5 to 9. Then I used lemon juice and baking soda to create the desired pH level in each planter. After doing some research, I discovered that using baking soda to bring pH up and using lemon juice to bring pH down will be the most effective way to alter the pH level in the soil because of the chemical properties. Finally, the last step would be to use a pH measure to ensure all planters have the required pH. If not, I would use baking soda or lemon juice to alter the pH to the desired level. As you see on the screen, there are photos of me during the first part of my procedure. This one shows me weighing the planters. This one and these two show me testing the pH. The second part of my procedure included planting and growing. The first step was to keep all 5 planters in an indoor location, away from direct sunlight, under a plant grow light, and I simulated a natural environment by turning the plant grow light on in the morning and turned it off in the evening. Then I planted 5 fenugreek seeds in each planter, and I kept note of each of their locations. Next, I watered each plant with 30 ml of water. I made sure that the water source is controlled and that all plants got the same amount of water and the same type of water each day. Finally, I took note of the plant height every day and listed my findings in an organized data sheet. I hypothesized that fenugreek growing in a soil with a pH of 6 will have the best growth. I came to this hypothesis because research shows that legumes like fenugreek tend to grow better in slightly acidic soil with pH levels from 6 to 7. Here is a summary of my data sheet, and you could see that it shows the data from week 1, the data from week 2, and the data from week 3. I observed that fenugreek grows better in acidic conditions, like soil with a pH of 5, because the plant grew faster, more seeds germinated, and the plant height was relatively higher. Here is a graph comparing the plant heights and the pH levels. You can see that the planter with pH of 5 had 3 out of the 5 seeds germinated, and each of the seeds grew to a total length of 1.5 inches. These results are better compared to the other planters. The implications of my study are that legumes like fenugreek develop a symbiotic relationship with the rhizobia bacteria, which live in the soil and help fix the atmospheric nitrogen levels. The rhizobia bacteria basically make nodules on the roots of the plants, and these nodules will fix the atmospheric nitrogen levels. They will strengthen the plant root and even increase plant growth. Therefore, the fenugreek plant can be also used to reduce soil erosion, as the nodules created by the rhizobia bacteria will help secure the soil in place. In conclusion, my experiment has discovered that soil with a pH of 5 provides the best short-term growth for a fenugreek plant. Although this is not what I had hypothesized, the data I have collected prove that legumes like fenugreek grow best in slightly acidic soil. Fenugreek plant poses many benefits to our environment and health, and studies like mine will open up more opportunities for more environmentally friendly growth. Thank you.
Oh, amazing.
Thank you.
Wow, I am very impressed. How the way you've organized this was incredibly good. How did you learn how to do that, to create this kind of a project?
So in my school, we have a very STEM-based curriculum. So we live near New York City in New Jersey. So we would frequently go to the Hudson River, which is a river near the New York area, and we would take the water quality parameters like turbidity, pH, like I used in my experiment, and dissolved oxygen. So our science teacher really guided me through this project because she knew. So she taught us many of the ways, and so what she taught us, I applied into my project.
Excellent, excellent. Anyone else?
Well, how did you get your presentation? Well, no. Did you when you said constants is a location? Technically, that is not true because the location on a coordinate grid would not be the same for all of them. So you got something wrong in your presentation.
So it's important when you do an experiment to keep all control variables. This makes the experiment accurate. You want to keep the same environment for each different factor, because if one factor changes, this can alter the conclusions of your experiment. So although I could not keep them in the exact same location, I kept them close together, but far enough so that they won't cross-pollinate, because that would also alter the conclusions of my experiment. But I tried to simulate the exact same environment for each of the planters to keep controlled results, to make sure that my experiment would get accurate results.
Yeah, thanks. It was mostly a joke, but your explanation was wonderful.
Thank you.
Yes, I would like to compliment you too on several things. Your presentation was really well organized. You spoke very clearly and at a good pace, and it was very easy to understand. That's not easy to do, especially for young people. That takes a special skill and it takes practice. You even dressed a part today, which I think looks really nice.
Thank you.
I appreciate that. And your analysis, again, your analysis of your data, putting it organized into sheets so that you can really look at it and keep track of it, is a skill that you have accomplished very young, and that will benefit you, especially if you want to continue along this path as maybe a scientist or a researcher. You're well on your way. You did a
Thank you
really
so
nice
much.
job.
Thank you.
I really enjoyed how you put the scientific method, or I forgot what it's called, but I really enjoy how you circulated your entire presentation through the cycle.
Thank you.
Something I really enjoyed.
Thank you so
But
much.
I have a question though. One of the things that you concluded was that the pH of 5 gave the best growth, but you didn't go beyond that. Why didn't you go to 4? Maybe 4 would have been even better.
So basically like I tried to do more pH levels, but it became really complicated with using the baking soda and lemon juice to bring the pH more down. Like I'd spend several hours trying to like bring it to pH of 4 and pH of 10. So I would say next time, if I wanted to expand on my project, I would very much consider expanding the pH levels, because that would be very interesting to see if pH of 5 is the best, or are there even more better ones. And I would also like to expand my experiment by testing the same method out with other plants other than fenugreek plant.
Very good. Did you collect any data about how the pH would change because of the growth of the plant? The plant is obviously growing and it's extracting something from the soil. So the
Yes.
question then is, how is the plant changing the soil?
So far I did not do any research on that, but that's an interesting point, and I guess I could research more in that.
I have a question. You might have answered it in your presentation, but what exactly about the pH level of the plant, of the soil, helps the plant grow?
So the pH is just a simple factor on the acidity, which like acidic substances can be like lemon, and alkaline substances can be, for example, the dish soap that you use is very alkaline. So the different alkalinity or acidity of the soil can affect how many nutrients are in the soil. And if there are more or less nutrients in the soil, that will affect if a plant can get more nutrients or less nutrients. And the plant needs a certain amount of nutrients to grow well.
New Jersey has a Department of Agriculture. Have you contacted them and offered to share your results with them?
I have not heard about the New Jersey Department of Agriculture, but yes, I guess I could share my results with them. And I was also thinking of sharing my results with the New York Department of Environmental Protection, which even in our school, we send our data that we collect of the Hudson River to them. So I was thinking that I could even send them more of my experiment, and I could also do it for the New Jersey Department of Agriculture.
Yeah, New Jersey has a large industry of growing crops, vegetables, and obviously not wheat, but they grow lots and lots of carrots and tomatoes and stuff like that. And I am sure that pH is something that they think about, and I think they would be very interested in hearing from you.
Yeah, but you should first finish like 4, 3, 2, and 1, or you might actually ask them for assistance on those kind of things, because then it would be way better, because you would actually have way better material.
Yes, I could do that, sure.
You might even be able to get a government grant to continue your work. And if the grant was large enough, you could drop out of school and just do this full time.
Yeah.
Or you could hire your science teacher as a consultant to help you in this project.
Okay. I'll think about it.
You mean you might not hire your science teacher? You might not want to hire them?
I could, yes, I could.
Be careful, they might be watching this video. So you have to excuse me, one more thing. Clearly, you have an excellent science teacher.
Yes.
I like to make sure that the people who make students like you successful get the recognition. So would you please state their name? Because you talked about the school, but who was the teacher who really guided you in this?
Okay, so there are two main science teachers which really helped me throughout this experiment and my overall science journey. Their names, they might be watching. The first one is Dr. Grace San Victoris and Miss Michelle Vello.
Great. Make sure they see this video, and it will make them very proud that they have helped you and that you have accomplished so much.
Okay.
As a
Thank you.
science teacher, don't you agree, Amy?
Very much so. Yes. Make sure you always thank the people that have helped you along.
Okay. Yes.
Very
So
nice job.
what's your next project?
So I haven't really thought about it yet. So I could continue on this experiment, which I would love to do, or I might even choose something new to work on.
There are different plants that might react differently to pH. You might want to try a different plant.
Yeah. So some of my future study could include, like you said, expanding the pH levels. Instead of just 5 to 9, I could maybe to do 1 to 14, which is the entire pH scale.
No. I have dealt with 1 and 14. They are really nasty materials. You do not want to go to 1 and 14.
Okay, I'll take that advice.
Okay, at least go to 2. That's fair.
Yes.
3.
Wait, so you're saying that 1 causes an atomic explosion? Because I can see the
No. They're just really, really caustic and nasty and acidic, and you really have to. You need an industrial safety lab to work with things that.
I'll take note of that.
Don't do that. But,
Okay. And aside from that, I was also thinking of expanding my study to not only fenugreek plants, but different plants to see how they react to the different pH levels.
very interesting. Great. Well, this is
Thank you.
wonderful. Thank you. This is very good.
Thank you so much.
I've learned a lot.
Thank you.
Great.